Okay, so now we look at trig integrals involving powers of tangent and secant. So we're looking at trig integrals with factors that are tangent and secant, okay? So here's our goal. Our goal is to either isolate a secant squared factor, because I know that the derivative of tangent is secant squared. So if I can isolate a secant squared factor, I have my du already. And all I have to do is change all the other factors to tangent. Now, this only works if there is an even power of secant. So if there's an even power of secant, you can do it that way. Now, let's say you have an odd power of tangent. Well, if you have an odd power of tangent, we're going to save that factor of tangent, a single factor of tangent, and we should also save a secant factor so we can get the derivative of secant, which is secant tangent. So if this is the secant going to be our u, then du would be the secant x tangent x dx. So those are the two things we're looking for. We're looking for either even powers of secant, so we can put it in this form, or odd powers of tangent, so we can put it in this form. So if we have one of those two, we can do this. So let's go ahead and try one here. Let's try this one. The integral of, let's say, the secant to the fourth x times the tangent squared of x dx. So in doing this integral, well, let's see. In order to use this form, I would need an odd power for my tangent, which I don't have. So I'm going to try to use this form. All I need here is I need to have an even power of secant so I can isolate two factors of secant. I can isolate out a secant squared. Well, I have an even power for secant, so I'm going to isolate a secant squared factor. So it's going to look like this. The integral of the secant squared of x times the secant squared of x times the tangent squared of x dx. This is going to be the du. Everything else is going to have to be written in terms of tangent, powers of tangent. So this is already a power of tangent. This one needs to be converted into tangents. So this is going to be the integral. And instead of secant squared, I'm going to write the tangent squared of x plus 1. That's the Pythagorean identity. The Pythagorean identity. Times the secant squared of x, tangent squared of x, dx. So now I'm going to distribute all of this, and I'm going to get two integrals. The integral of, well, tangent squared times tangent squared is tangent to the fourth x dx. Oops, not dx. Tangent to the fourth x. I can't forget to distribute this. That's the most important part. Secant squared of x dx. Then if I distribute this to the 1, I get plus the integral of the tangent squared of x times the secant squared of x dx. Okay, so now if you notice what I have two integrals that look exactly like this. Tangent to a power of x times the du, which is the secant squared of x dx. Tangent to a power times du. Tangent to a power times du. So I'm ready to do my u substitution. They look both exactly like that. So if I let u equal the tangent of x, that means that the derivative of u with respect to x, du dx, is equal to the secant squared of x. So that means du is the secant squared of x dx. Great. So what I have here, this is u to the fourth power, the integral of u to the fourth power, and this part right here is du. Then plus, this one here is u to the second power, u to the second power, and this part right here is our du. So we're saving factors for our du. That's the whole point of most of the stuff we've been doing with these trig integrals. And then we just integrate. This one is 1/5 u to the 5th. This one is 1/3 u to the 3rd. And then plus c. And then we just have to back substitute because u is the tangent. So this is 1/5 times the tangent to the 5th of x plus 1/3 times the tangent to the 3rd of x plus c. So this is that integral. And all I had to do was isolate the du. Isolate the thing that eventually became du. So if you know what the integral, what the derivatives look like, this is relatively easy. So let's try another one. Now, if you remember, the other case we were aiming for was when we were doing the integral of, it would have been the secant to the nth of x. And then the part that we're trying to isolate is the secant x tangent x factors, so that we can go ahead and do a u substitution here, so we can get u to the nth du. So let's take a look at an example where we can do that. So let's try secant cubed of x times the tangent cubed of x dx. This one looks very similar to the one we just did, but notice I cannot find an even power of secant. I only have an odd power of secant. So what I'm going to do is, well, since I can't use the method that I used last time because I don't have an even power of secant, I'm going to aim for this one here, and I'm going to isolate a factor of secant and a factor of tangent so that I can have a secant tangent. Then I'm going to change all the other factors to secant. So let's see. I'm going to isolate, well, I have a secant squared of x, I have a tangent squared of x, and I'm going to isolate one each of a factor of secant and a factor of tangent. So I've just rewritten the integral. All right, this is my du that I needed, right? Secant x tangent x dx. All I have to do is make the other parts, the other factors into u, secant. So this is already a secant, that's great. This is the secant squared of x. This one, well, I'm going to use the Pythagorean identity. The tangent squared of x is actually the secant squared of x minus 1, based on that same Pythagorean identity we've been using. And then we get secant x tangent x dx. So now this is the du that I'm going to distribute to all these secants here. So I'll have secants to the nth power and then secant tangents for the du. I'm also going to distribute the secant squared. So I'm going to get two integrals. The first one is going to be, well, secant squared times secant tangent dx. Secant squared times secant squared is secant to the 4th of x. But then I'm also distributing all of that, which is secant x tangent x dx, which looks exactly like the form it's supposed to look. Secant to the 4th, secant tangent. Then minus sign, minus, and now I have secant squared times secant tangent dx. So that's the integral of secant squared x times secant x tangent x dx. So now I have the integral prepared. I'm ready for the u substitution. So I'm going to let u, in this case, u is going to be the secant of x, and in each integral is going to be raised to the nth power. So this is secant of x. In that case, du is going to be the secant x tangent x. So that du is the secant x tangent x dx. So this is what I'm going to use for du. And I have that in each integral, secant x tangent x dx, secant x tangent x dx, and u to the nth power, So now I'm going to modify all my integrals. This integral is u to the 4th power, the integral of u to the 4th power, and this all is du. For the second integral, minus, this is the integral of, well, this is u to the 2nd power, u squared, and that all is du. So now I'm going to do the integral using the power rule. Let's see, this is 1/5 u to the 5th minus 1/3 u to the 3rd plus c. And then I just do my back substitution. So this is 1/5 times the secant to the 5th power of x minus 1/3 times the secant to the 3rd power of x plus c. And here is the final answer for that integral.